So welcome to this panel. And what we will be focusing on is to explore the research directions and the most promising research directions which would shape 6G in future. So I have a very distinguished panel with me. And the format of the panel, we have tried our best to keep it as interactive as we can. So we won't bore you. Rather, we would try to engage in some interesting discussions. And please feel free to share your mind, ask inquisitive questions, which can trigger some good discussion here. So we won't bore you with any slides either. So we will try to directly go into a panel discussion, interactive panel discussion. So I would request my colleagues, panelists, to introduce themselves. But at the same time, I'm putting in and posing in a question as well alongside that introduction. So just identify one of your most favorite technology that you think will shape 6G, and it's ready to do that. So we can start from.
Okay, thank you, Mohammed. Thank you for introducing this. So I'm Christos Masouras. I'm a professor of wireless communications in University College London. I've been working on physical layer communications for a while. In the last 7-8 years, we've been working on ISAC. So that's my favorite, Mohammed. So I've been working part of SNS projects as well recently on this topic, doctoral networks on this topic, and also I'm part of an ETSI industrial specification group on ISAC as well. So I think I have a clear favorite for you, Mohammed.
Great. Over to you, Julie.
Thank you. How you doing all? I'm Julie McCann. I head up the School of Convergence Science in Space, Security and Telecoms at Imperial College London. And I also head up the Cheddar Communications Hub. Right, you asked a very detailed question. You said, what's your favorite? And then you also said, ready for 6G. So my favorite is also ISAC. I love ISAC. I come from a sensing community. All my life I've been doing sensing on its own and communications on its own, and then now we do it together, and I love it. But I think the work that I find also very interesting is around the openness, open architectures. I find it very exciting. It reminds me of the operating systems world when I first started, and I could see a whole world of interesting technologies coming from that.
Great. Emilio.
Yes, hi. My name is Emilio Cavestrinati. I work at CEOLIT. It's quite a big research center in France. I'm a strategy innovation director there, and also leading the program 6G. Definitely, for people who know me, I'm not only an enthusiast, but probably also a drilled person on semantic communications, which actually is the new paradigm that's driving the real innovation, AI native and networking. And I'm also lucky to be the coordinator of 3 key SNS projects at the moment working on the topic. One is 6G goals, completely focused on semantic goal-oriented communication. The other one is 6G DISAC, actually, which actually is on distributed integral communication, semantics everywhere, sensing and communication. Actually, we have 1 of 3 pillars is on semantic there. And the third one is a 6G ARA, where actually it's the collaboration between Europe and Korea, which is an AI native systems, which of course include this semantic communication part.
Richard.
Okay, I think my thing has run out of battery, so if I can borrow this. My name's Richard Penty. I'm for most of my life at the moment, I'm head of the School of Technology here in Cambridge. So that covers engineering, computer science, and for some reason the business school. But for some of my time, I'm allowed to do research, and so 2 main areas that I'm interested in. One is photonic integration, but the one I think is more relevant to 6G, though not very relevant, is quantum communication. Certainly, some aspects of the 6G network will benefit from quantum communications.
Okay, great. Over to you, Kentaro.
Okay, so my name is Kentaro Ishizu from NICT Japan, and actually my PhD is in computer science, and my career started from wireless communication technologies. So I'm always try to harmonize the different technologies. So that's why I'm here, and my mission is create good beyond 5G architecture, 6G architecture to harmonize different technologies because it's very important in the future. So I'm also trying to facilitate cross-industry talk with ICT researchers to create new values in the next future society. Thank you very much.
Yeah. So your favorite technology?
Okay, my favorite technology is orchestration, if I can say this is technology.
Great. Thank you very much. So just a request to audience as well. So just be prepared with your questions. Very, very soon we will be coming back to you to participate and engage in this panel. So maybe we can make a start with something that has been discussed this morning as well with some hints. So for all previous generations as well, 2G, 3G, 4G, even 5G, there has been this tension on what industry wants and how ambitious the researchers are, right? So researchers come up with very innovative, revolutionary type of technologies, and industry is always pushing back for evolution for some good reasons. So what I would like to know, maybe from a couple of panelists, what is their opinion, how we can bridge this gap and make sure that the research innovations are taken seriously by industry and standardization committees, and we slightly expedite the speed at which we are developing these generations. So who would like to go with this question? Yeah. Please, Christos.
I can give you an example of from my experience. One of the venues that I participate, as I mentioned, is ETSI, which is a pre-standards forum. And I believe that's one of the ways where us academics can kind of influence where standards are going. It's not like everything out of ETSI is going to go into 3GPP, but perhaps there's some influence that we can have in the directions. And one very particular one I have for Isaac, and I'd be happy to elaborate, is on the security challenges for Isaac, because I think that can be a showstopper. So through ETSI, we have a work item on security that we're hoping to somehow push awareness into 3GPP. Perhaps not specific technical contributions, but at least some direction.
Okay. So the other question I have, and I'm sure it will be in the minds of many of the audiences as well, because everyone has heard the AI word today several times, hundreds of times, yes? So AI seems to be the holy grail for the success of, say, 6G. It seems like in the standards as well as in all discussions. So the question I really wanted to ask and check with some of the panelists before going to the audience as well to see their views. AI has not been a new invention. The maybe terminology might be. We have been talking about since 3G, smart networks, and then self-organized networking in 4G, and in 5G as well to more extent we have been discussing this. What is stopping us to have that AI really working in deployed mobile networks? So why we are waiting for 6G? So maybe, Emilio, we can start with you, and Kentaro, maybe you can add something to this.
First of all, I would say that there is a dual system. No, in the sense that actually there's a 6G needs AI for optimization, but at the same time, AI needs 6G for feeding with data and use cases and testing and so on. I was actually listening to the NVIDIA CTO keynote this morning when I was coming here, and actually, from point of view of the heavy industry behind AI, the bottleneck is for sure the computing power, and actually the scalability. From the point of view of 6G, AI actually is needed because of the complexity we are bringing to the network, and indeed, again, the scalability, and somehow to reason the complexity in computing, in caching, in communicating. And one example, we've been discussing a lot about this terrestrial communication, for example. We actually, with a claim we need terabits per second communication in the communication, but indeed, most of the case we actually can reduce and put to the sense the communication part by actually compressing, not only transfer bits, but actually going to the meaning, the semantic of what we send. Actually, AI is bringing the possibility of changing the paradigm of what is the information we're sharing. And actually, if we want to really go to the next step, so one way for sure is about the quantum, but in general, if we change the paradigm, I mean, Shannon has been there and actually is driving us in 75 years, but now the world evolved and we can do different things. So the approach to information should be pragmatic to what is needed to the receiver, which actually now is the intelligent receiver. So it's a completely different way of structuring and so on.
Okay, great. So, Julie, you want to add, and then Kentaro?
Okay, yeah, so I wanted to add, I've got mine. I wanted to add also that AI has changed as well. Our technologies are changing. the computers that run the AI is changing as well. It's becoming more efficient. And we're seeing the AI evolve far faster than before. It always bloats out and then hardware has to catch up, but that's the way it goes. And so that gives us opportunities that we perhaps dreamt of before, now that we can actually realize. And also, because of new paths in AI that we didn't think so much about, the more generative side, we're starting to think, we can use these as tools. We can use these to help people configure the system, the human in the loop thing as well. So I think AI itself evolving is impacting the whole arena.
Yeah. So you have anything to add quickly?
Yes, and in future there are a lot of different types of systems, and we need to combine. At the time, maybe human cannot come up with the best combination, and to use such resources of different systems from different industries, maybe we need some kind of AI to fully utilize such systems. Otherwise, maybe human cannot do anything. So from that point of view, AI is very important. That's my opinion.
Yeah, Chris, you want to
If we have time?
Yeah, okay.
I just wanted to comment on AI for communications.
Yeah.
Because I think it's important to know that communications applications are different to computer vision, where AI started from. So we have dynamic environments, we have things changing all the time, topologies, channels. We need to be able to use lightweight AI and efficient AI. We also have lack of data. We need to gather data quickly. So one thing is communicating around to share data to train networks. That's communication, but there's also the issue of acquisition of data. And again, my favorite technology, I believe sensing can also help there in acquiring real-time data and informing learning approaches.
Okay, great. So one technology that I was a bit surprised was not mentioned by any one of you as your favorite technology, but it's very common in research at the moment, is reconfigurable intelligent surface, right? So maybe Julie and Christos, both of you, because you mentioned other sister technology, which is integrated sensing and communication. Would you like to comment both of these technologies, how far they are from commercialization or actual real-world deployments, and how they can help each other, especially how we can benefit from risks to improve ISAC? Maybe, Julie, you want to start?
I could start the second part of your question. How does a RIS improve ISAC? Is that what your question?
Mm-hmm.
Okay, so well, the same reason it's going to improve communications. You can control and bend the signal to maximize the communications. You can do that for sensing as well. Mm-hmm. In my opinion, the opportunity for commercialization is quite soon. I have to say the early commercialization versions that I've been playing with have been awful hard to configure. You know, for someone who wants to move into it, who's not down at the very lowest level of the physicality, it's probably easy for you, but really difficult for someone like me to have to configure that thing. So I think we need more tools and so on at the moment. But I'd like to hear what you think.
I'm actually one of I would say the skeptics of this technology.
Good.
I was a bit skeptic, but I think I can see a couple of much better experts than me here who can discuss as well. Yeah. But my point was, beyond the technical challenges, I think there may be business challenges. We've seen other technologies that have stopped because we're not able to. The business model doesn't work when you have to put the RIS up somewhere and pay rent for it and have all these installation costs. So I wonder whether RIS will find applications in private networks or control environments, with the particular opportunity being, in my view, near field opportunities, stuff you can do in the near field.
Good. So it's good to see some disagreement in the panel. But Julie, you wanted to come back on this?
I wanted to follow that because I'm lucky to have been Vice Dean for Research in Imperial, right? And what you get to do is you get to go and see all the research in the materials labs and what's going on, in the built environment and all those things in civil. And they're really keen to include meta surfaces in as part of the infrastructure. They're really keen if it makes their environment smarter in some way, or that they can get a return on it. So some of the maybe impediments that are what we have now may not actually be an impediment in the future.
Yeah, that's great. And this very quickly and very nicely links to the next part, which is, you mentioned that these are very difficult to configure, right?
Yes.
So
Sorry.
if there was a self-organized configuration or self-configuration type of mechanism,
Yeah.
it would be easier for people who don't have that physical layer knowledge to
Yes.
deploy them. So on that one, Emilio or Richard, both of you can contribute to this one. What do you think, how, for example, AI as well as semantic communication can help in self-configuration of these kind of difficult to configure things?
Well, you do the semantics, so I've no idea. I mean, I think it will absolutely be necessary to do self-configuration in some way, because you're not going to set these up, and they'll want to reconfigure as network conditions change, as people move around with their mobile devices, as as the weather changes. Even, I mean, it will definitely need to be self-configurable and very reconfigurable. So how you do that is then becomes more tricky, and how much accuracy you need with the beam steering, etc. The other thing I'd slightly worry about is is the longevity of such surfaces, because if they're based on metamaterials, then the metamaterials might degrade over time. So you'd have to be careful about which type of metamaterial you used, and some will last much better than others, and some will be less susceptible to the elements, for instance. I'll hand over.
Yeah, so about the configuration problem. So indeed, let's say when we did some experimenting with RS in our labs, and actually the point that you have a set of optimal setting, and then you have other one that actually present degradation for that. So the point is that, first of all, with AI, you're able to identify different potential setting, and then the idea, for example, with the part of the communication can robustify communication, like for example with semantic communication, then you can degrade what you need from the RS but still make it work. So I mean, let's consider a different way. You have a beam forming. No? Instead of you need to have a very narrow beam to have the gain you need, you can accept our wider beam. Still, the gain is enough because you have a compensation from point of view of semantic communication. And then either if the user is not exactly where you think it is, actually you can still reach him with the right way. So the point that, for example, with RS, what we saw, the problem if you want to have like 16 users served by the same configuration RS, how you do? And actually, the way forward we saw with this AI-driven approaches, where actually you can have compensation from the terminal side, different kind of settings which are not optimal but still decent for everybody. As for example, the approach of semantic in another way, then you can solve the problem. You can accommodate
Address,
a solution to a problem.
So I think this leads to another interesting area, which is spectrum, and it was mentioned in the morning sessions as well, that even millimeter wave hasn't taken up much, right? So what we are talking about now, pencil beams and pointing them to a specific direction on a wrist so we haven't even done millimeter wave yet, right? Terahertz is not getting a lot of traction, as was asked in previous panel as well, in standardization. So I just want to realign the real world scenario with what we as researchers are trying to achieve. So where do you think all these technologies converge, or what time frame you see they might be converging? So anyone who wants to comment on that?
If you
You
want,
can
I can start
yeah.
at least. So why, first of all, from my point of view, millimeter wave didn't fly enough was actually, first of all, for energy consumption. Yeah. But second thing, if you really dig into the hardware, okay, if you really want to conceive an hardware working there, actually then the silicon process we have don't really work in an efficient way, to the frequencies. And if you go to terrestrial communication, the problem is that some of the frequency between 130 and roughly 240 gigahertz, there's no silicon technology that really works there. They can deliver the power you need. So there's what they call the dead valley there. So we have some products in research, but not in the scale that we can do it in the industrialized way. So that definitely is the problem we have. So the real key point is that the time to service of a user was actually, if you really drain the battery in a few seconds, a few minutes with a millimeter wave, indeed these are benefits are not there. So I would say that the paradigm ongoing for the next generation, 1,000 times more capacity, is over. Okay, now the time is really to use the intelligence to squeeze down information you need to share.
Incremental.
And actually then, when you use millimeter waves, when you use terrestrial communication, indeed, by relaxing a little bit the exigence about the the quality of the speed of the link, and can you still use in a direct way because you have a kind of compensation from other mechanisms driven by AI.
Yeah. So Christos, a follow-up question about, you mentioned as your favorite technology, integrated sensing and communication, as well as working in different spectrums like terahertz and millimeter wave. Do you think there is a need to revisit the waveforms as well, especially for joint sensing and communication?
I mean, that's been the key question, I think, from the beginning. Again, my honest opinion is I don't see OFDM going away very soon, but there may be corner scenarios where other waveforms have advantages, like OETFS or like overarching technologies like AFDM. We're going to have to see what are the fundamental trade-offs across communications and sensing. We know now with recent results that OFDM is actually optimal for sensing with random signals, so payload signals in single antenna systems. And that remains to be seen if it's the case for MIMO and more complicated scenarios.
Great, thank you. Richard, you wanted to add?
Yeah. Well, just to go back to the sort of spectrum question again, and I mean, I agree, terahertz and millimeter wave, they're difficult technologies, but they are evolving. They are getting better. Whether they're better in time for 6G, I don't know, but they will get there, and certainly, it's obvious that as you go up in data rate, you're probably going to have to go up in frequency. And the other obvious thing that you didn't mention, obviously, is light, though. So obviously we have Harold here, very lucky at Cambridge to have recruited him from Scotland. He's running a group doing some great work on using light for 6G, and there's some pros and cons to light, of course, but my view is that 6G will not use, well, obviously it won't just use one technology, it'll be heterogeneous, and light could well be something that could be used in 6G.
Great. So I would come back to Chris, just while we are with Richard, just one more challenging technology which does not seem to be immediately applicable in 6G, which is your favorite area of research as well. So what do you think about quantum communication? Would it be 6G, 7G or beyond?
Well, quantum communication is a bit of a misnomer because, at least at the moment, it's the sort of industrially deployable stuff is really key distribution. So using qubits to distribute keys rather than do the communication itself, and that at least at sort of a fairly the first level of quantum communication is already here. Toshiba have built a factory in Cambridge to start building QKD boxes and shipping them if you want to buy one. So where might you deploy it in a 6G network? You certainly could deploy it in the front haul, the back haul systems, the fiber-based systems that make up a lot of the 6G network. And people are deploying it now. They're not deploying it at scale. They're deploying it in in industries which really do value security, and they're probably deploying it with a layer on top, which is post-quantum cryptography. So both a more secure cryptography and a more secure key distribution technology. And one's banking and others defence. They're the two main places. And it was mentioned in one of the talks, I think it was from NICT, there's a lot of interest in deploying QKD in satellite networks, and there's a good reason for that is because once QKD is very limited in range by loss. And so if you, once you've got up to the satellite and you can communicate between satellites over, right across continental distances, and the quantum communications hub is launching a satellite very shortly from Scotland, and we'll be sort of doing that in collaboration with Canada.
Yep, and that naturally links to another very interesting research area, which is non-terrestrial networks. So, Kentaro, would you like to share some views about non-terrestrial networks and what role they have in 6G, especially their integration with terrestrial networks?
Yes, NTN is very expected. I think, especially for example, in Japan, we have so many disasters every year. We try to prepare for the next time, every time, but we cannot avoid such disasters. We cannot avoid victims. So actually, in Japan, more than 70% of the land is mountain, and it's very difficult to deploy base stations anywhere, and we cannot cover whole land with mobile systems. So NTN is very expected, but only with NTN, people cannot use. So the integration of NTN and TN is very, very important. And also Japan is maritime nation, like UK. So for many activities, we need NTN. So from that point of view, so NTN is very important. But my point is integration is very important. Only NTN is not very easy to use.
So maybe we collect back some of our views, especially one area which is very important, but we have not discussed it yet in the panel, is security and resilience of 6G networks. So would that become somehow integral part of design of 6G, or do you think it is something which is just like all previous generations, a separate add-on to the future telecom technologies? So maybe Christos.
So I believe, if I speak for Isaac, for example, which is coming in 6G, there's going to be a lot of new scenarios relating to data confidentiality and data security, and there encryption may have a role, but we perhaps need something more. But there's going to be entirely new scenarios, so once you have sensing within the cellular infrastructure, you're going to have issues with sensing security, sensing privacy, unauthorized sensing, which are things we never had to deal with in a cellular system. And in these scenarios, there's no data link from A to B. It could be about an entity using passive sensing with the good Isaac signals now to do its own sensing of very private information, crowd monitoring, vital signs kind of sensing. And there's no encryption, and we need physical layer approaches.
Richard, you want to add something to this?
I mean, I think we've seen all issues this week around, insecure communications, like that, whatever that channel was that the American government decided to publish their plans on. So I think there are multiple levels to security. I mean, there's encryption, there's physical layer, key distribution, like quantum can do, but there's also other forms of more secure ways of communicating. But the other thing we need to worry about, I think, though, is take that American example. You need to be very careful about the human behaviours, and most failures in security are often down to humans failing to take good processes themselves. We in Cambridge had quite a major cybersecurity attack in our medical school a few months ago. Nearly a year ago now, actually, and it's and they still, some of the research groups still haven't got their data back. It's still encrypted, and that was because somebody was subjected to a phishing attack. So we need to increase our human security too, and come up with better ways, I think, of trying to make sure our systems are less susceptible to attack.
I think we have covered some basic ground. So yes, Emilio, you can add to it, and then we go back to the audience. So just audience, be ready with your question. Next one is coming towards you.
Just a funny part, and I'm sorry. I was giving lectures a few months ago to a telecom operator. And actually there was a couple of people from the government there present, expert in security. And I would say actually, so the lecture was about 5G and 6G. Actually the point derives from the point of the government that they don't trust at all 5G for security, because actually has not been conceived at the same time of the security problem. And actually the big challenge, they are expecting that we do that in the same time, security and 6G. And actually, the reason they were pushing is that we are creating an automated system which actually is able to control, decide, actuate, and then we are propagating intelligence around the network without having a structuring solution for controlling, driving, and so on. So without giving solutions, maybe also opening a little bit to the others, but actually the big problem is that as today, as the beginning of 6G, I don't see this trend change. I see, again, we do security, one part, and we do 5G and 6G, another one. In my group, for example, I have 100 people roughly working on security, but still do not then really dig into the problem of 6G, and the guys on 6G, they're not digging into the problem of security, indeed, because there are some kind of different background and knowledge and so on. But these, we are repeating the problem. So, for example, now, for some application, 5G will not be granted for a long time.
So because of AI, we are taking human out of the loop and we are automating a lot of systems, right? So do you think it will help or it will make the problem worse?
I mean, there's this agentic AI approach, that can help and kind of AI secure coach around you, roughly. There is some example, this application for text messaging where you're drunk, the application just asks a power question. If you look to be drunk, you don't send a message.
Yeah.
So it can be somehow in a different
way. It may help, yes.
around that.
So floor is open for questions from the audience as well. Let's start from here. Yes, if we because last time that side was very active, so that's why we are starting here. Yes.
Oh yeah, so Ari Potto from the 6G flagship University of Oulu. There are a lot of talk about ISAC, and now when you think about imaging and sensing, the accuracy and granularity of your estimates become better when you go higher in the frequency. Now we're talking about FR3 for 6G. Now, what's the role of ISAC in 6G? And is there a better approach by using multimodal sensing? We have cameras, it's easy to put the radar chips in your phones. So what is the role of actually ISAC in 6G?
Maybe I make a start. So absolutely, I agree. Multimodal sensing is in my mind, a form of ISAC. So whenever RF sensing doesn't cut the job, there's other modes that you can use. Now, relating to frequency, indeed, this is the question also about millimeter wave and terahertz, where we're waiting to see what happens for terahertz. We're limited by physics in terms of monostatic sensing, but then what we cannot do with monostatic sensing in terms of granularity and resolution, we can probably get some help by cooperative sensing. And that's why I think doing things distributed and cooperative in the ISAC domain is going to be important for the next few years until we find out what's going to happen with the higher frequencies.
Julie, you want to add anything?
Yeah, I was just going to say, though, with what we've got already, we can pick up an awful lot of interesting things. The human movement. Mohammed's team's been doing vital signs. There's a fair amount of things we can do, and as we've just heard, the distributed nature of it means that we can start to get awful clever. Now, of course, you can have it as a part of a multimodal solution, but if the whole reason for using the RF end of sensing is to do with things like, for example, people don't maybe want cameras in a certain situation, they won't sign off on the nosiness of cameras, and an RF solution is considered, and I put that in inverted commas, slightly less nosy, indeed. But horses for courses with sensing, generally, But you kind of get it a wee bit for free, so why wouldn't you?
Great. Okay, so there's another question from the same side.
So Nicholas Rafinovsky with FTH. Thanks very much. Great discussion. Building on the ISAC topic, we have this beautiful, fast forward, it's now 2034, 2035. We have 6G deployed everywhere. ISAC is now a native capability built into every mobile device, every base station. And the structural problem that Emilio presented is very, very, very real. Security folks are out here doing their own thing, and then we have to monetize it, we have to build it, we have to deploy it. We're going to go ahead and do these things, and we'll worry about security a little bit later. So that's the scenario in which we live. This is 2035. This is, in my view, a highly probable trajectory. two questions in this scenario. The first one is, how do we prevent the two siloed approaches, which is what's currently the trajectory? And the second one is, how do you consolidate the capabilities that ISAC has now and the legal requirement for legal intercept coming in for 3GPP aspects? So they are, in my head at least, mutually exclusive elements with the level of security that you need. So over to smarter people.
Amadeus, you would like
I mean,
to?
I can start with a almost not scientific answer, but say that a not pleasant way to do for us probably would be regulation. I mean, actually, you force technology in order to have, for example, you have different grade of, I mean, you go to TRL 1, 2, 3, 4, 5, and every time you have to have a kind of agreement about the security level you have. That would be, from a point of view, a very structured way to do. Maybe us as academics don't like that, but actually there would be a way.
Okay, great. Any other questions from this side? Yes, please. We will come back to this side as well,
Sorry,
for sure.
another one from this side. I just want to talk a bit about use cases. So one of the things that plagues us till today is outdoor to indoor mobility, right? And this is a convergence that's not happening starting from 2G. We know that this is a problem. So I'd like to get panel's view on what technologies may actually help here, and if there's any. Kenaro talked about NTN and TN conversions, but what about simple problems like indoor communication, indoor data communication?
And when we are talking about use cases, maybe if panelists want to also bring forward any useless cases as well, which 6G should not be focusing on. So please feel free to do so as well. Yes.
Yeah, I think that's a great question. I mean, you know, when 3G came in, you know, there was this joke that, you know, in the old days with landlines, you know, you're in the garden and the phone went, you went indoors to answer the phone, and you know, in 3G the phone went, you went outside to get a signal. So, and that's basically what you're saying. So, you know, we in a former set of research we did, we used to do radio fiber distribution of signals inside buildings to get over that problem and span out a company to do that. So I suspect that going back to my original point about heterogeneity of the technologies that the mobile device will have, I think that's probably the way. I can't give you the exact answer, but for instance, whilst light can work outside, you know, it's probably much better indoors for very high data rates. And so, you know, Li-Fi, as Harold has worked on, but outside it's much more difficult to do that with mobile devices. Whereas, you know, clearly the radio signals are much better for connecting people outside, but you're not going to get the data rates that you might with light. So it's not a great answer, but I think heterogeneity is one way of approaching it.
Yeah. Anyone else wanted to add anything? Or
Okay, so different technology, different frequency, for example, has different pros and cons. So we need different frequency band has different features.
Yes.
So we need to select proper frequency band, proper systems for expected use cases.
Yes.
So for that, we need some decision-making system in the, maybe, I don't know, in the core network. And depending on the situation or use cases, applications, or user demands, the proper systems need to be selected. Otherwise, we cannot always use terahertz band, for example. We cannot always use a sub-6 band. So this kind of decision making is very important for future networks, because only one system cannot meet the user requirement. So that's one point. Okay, so hand over to him.
I just want to focus next on a part. So about the problem about indoor to outdoor or vice versa, you know. Actually, there's a technology we tested in a real proof of concept in in a train station where you have this problem indoor-outdoor, which actually is the RS, kind of contagious surface. Actually, the problem you have is discontinuity of bad environment. Now, where you can control the environment in the bridging part, actually helps. So we show, for example, in that case, I mean, actually is a good use case for RS, where you have this mix indoor-outdoor, you need to migrate, and actually the benefit of being able to control somehow the propagation environment really comes to play. Actually was the case of this RISE-G project and a year ago. We show in the Rennes station in France, actually, that really work with people around and so on. Yeah.
Great. Christos, you wanted to add something? Yes.
Yeah, something on the point of heterogeneity. That I guess a challenge there will be the handover that you need to do with the two systems. So you would need perhaps to exploit prediction, perhaps to exploit other things to facilitate that with small latency. And guess what can bring you that? So my favorite technology, I think, comes back.
Comes back again, yes. So maybe we sweep our beam gradually in this direction. Okay, so Ali, yes. We will come there gradually. So beam is sweeping, yes.
Just a quick question that in terms of ISAC, how do we see the split between the cellular and indoor Wi-Fi, for example? Because we already see in Wi-Fi world, some of the sensing capabilities are being built into Wi-Fi standards, for example, today. So is there another case, is this another situation where Wi-Fi is leading cellular slightly?
We'll go with Kentaro.
Okay, so this is not just related to just ISAC issue. Maybe I'm wondering what is 6G? The 6G on the name of this symposium may be different from the 6G defined by 3GPP. Maybe the 6G here is wider, and maybe we need to integrate 3GPP system with other systems like the non-3GPP systems, and that's what we are saying as 6G here. So this concept is very important here.
Yes, a lot of these technologies we are discussing are not going to be in release 21. Yes, so that's an interesting and important point. So anyone wants to add to this comment? Otherwise, we have a question back there. Yes.
Hi, I'm Holger Clausen from Tyndall National Institute in Ireland. You talked about your favorite research advances. Could you tell a little bit about what does it enable for the end user? What are the new things that we will be able to do when you realize what you're researching?
So how all this innovation will look like to the end user? What will it change for them? Right. So anyone wants
Want me to start? I could start on that.
Yeah, please.
Right. So what? And you can pick up as well. So one of the things I like about the joint sensing and communications thing is that the end user, for example, doesn't have to wear lots of sensors if they're ill in hospital, potentially. The end user doesn't have to have a lot of nosy cameras around, but you get a lot of the sort of monitoring without the creepiness. Ish. I say that ish because it's not really. It's still creepy. And because we can get a lot out of it. But also, from a sustainability point of view, if you're kind of piggybacking a technology onto another technology, you're saving in cycles, so it's energy, but you're saving in materials, you're saving in copper, and there's a nice sustainability angle on that. So you're kind of, if you're ditching one set of technologies because you're piggybacking on another, there's that potential as well.
Great. Okay.
I mean, on ISAC, as you probably know better than me, there's 3GPP has 32 use cases. ETSI has defined another 18 use cases. All of these are, I mean, healthcare is one, connected vehicles is another domain. Automation, so ICIA has also defined its own use cases. So these are, I mean, depending on the use cases that actually happen at the end, I believe, yeah, indeed the end user will see benefits in one way or another.
So, Saranjoy, there is one question here, and then we move here, and then. 3 questions lined up. I think there is one there as well, 4.
Well, thank you very much for this discussion on ISAC and AI. I'm really struggling with the dichotomy in the sense that I see ISAC as very much of a real-time advanced signal processing, adaptive systems type approaches, whereas AI one would see is a backroom, offline technology. How do you marry them together?
Okay, who will go for that one?
To me, they're kind of orthogonal. One helps the other. I mean, one of the reasons we can do the ISAC that we can do now is because we've got advanced machine learning and so on mechanisms. But we also do a lot of edge compute. I mean, we're computing a lot of that processing on the edge. So it's not necessarily uploading loads and loads of signals back to some big back-end system. I mean, how much of yours would be that heavy?
I was going to say the same. I mean, my impression is that AI for comms or ISAC is no longer an offline kind of thing. It has to be dynamic and on the spot in real time if you want to respond in specific scenarios. And you don't have the opportunity to do huge computing, right?
Yeah. So there is a question, Bruno, if you can bring the mic here. Yes.
Yeah, my question is about power consumption. So I think Ericsson showed last year that 80% of the energy consumption in mobile networks comes from the radio access part. So I was wondering, what is your opinion about this and how your solution will address the issue of energy consumptions?
So would AI, for example, have a role in reducing energy consumption in radio side, right? So or something else? Yes, Kentaro, please.
Okay, so we have an interesting trial. We have an interesting project that depending on the human flow, maybe if we can understand that some area has no demand for communication, maybe we can stop the radio unit. So maybe we need to use AI, but depending on the situation, we can sometimes stop some equipment. And this kind of technology would be beneficial for energy consumption reduction. And if we use ORAN, there's some interface to control the network, and maybe we can use the interface to control the radio unit, and this kind of idea could be possible. Thank you.
So a quick comment from you, Christos. We have 3 more questions. So one is just behind you. Next.
I had 2 points. I'll try to make them quick. Sure. So I fully agree with Bruno. Yeah. And what really concerns me is in the context of ISAC, when I hear operators saying, "Oh, we don't have to integrate. We can put another sensor." And that's only going to worsen this percentage that you talk about. So I think full integration is going to be key here. I think in maintaining energy, not just the consumed energy, but the embodied energy. So the energy to, put the devices together. And I think in answer to that, also, I mean, there's a level of where that energy comes from. And I think for future, if we talk about sustainability, we're gonna have to look at the integration of networks with renewable sources and how we manage energy from renewable sources, from the smart grid, and so on.
Okay, so maybe we move on, and just there are a couple of questions left, and I'm conscious of time.
I wanted to ask about accelerating commercialization, because the technology is amazing, and we've had this discussion about when will it be ready and will it be commercially viable. What are your experiences of where you have seen something commercialized quickly and well, and how should we think about how we fund research, whether that's public or private, in a way that incentivizes that to happen most appropriately?
Thank you very much for asking that question. That was my last question, so already covered. So who would take that question?
I can start.
Yes.
Software. I've seen people do innovations in software far out really fast. Go out and maybe not even bother to get to far spin out and be bought by Google or something like that. So a lot of software. A lot of security software as well. That's where I see.
So Julie, for that, I remember Harold's comment as well. So how do you marry those 2 comments, right? So hardware is also very important to run that software.
Deep real hard. That's all I'm going to say there.
Okay.
Deep tech's real hard to go out fast.
Okay, any other? Yes, Richard, please, and then Christos.
Yeah, and more generally, I mean, I agree. Software is probably one of the things that you can get out quickly. And in Cambridge, we've had many spin outs that have been bought for insane amounts of money without much investment. But I think that the other thing that more generically helps is if you have an entrepreneurial ecosystem. So, without wanting to boast too much about Cambridge, we have had a very long history here in Cambridge, and it's not all been run by the university. There's been a lot of local industry and local entrepreneurs who started doing things, made mistakes, of course. The Sinclair C5 bike, you'll remember. But that was the first electric vehicle. Here we've built up an ecosystem where we've got all sorts of people that are involved. So we've got the angel investors, we've got the early investors, we've got the bigger investors, we've got loads of people with great ideas, and we've got people who aren't afraid to go out and set up a company and try and push something. A lot of them fail, and you've got to let them do that. That's important. But if you can get that system together, I don't think good technologies on their own work. I've spun a couple of companies out. They've been technically successful. I'm not rich, but it takes an awful lot of hard work and effort to spin something, and you just have to get on and try and do it.
Okay, so there was a question at the back as well, maybe, yeah. So would that be the last question, or anyone else has any questions so I can plan time? Okay, one more question.
So
sorry.
I have so many questions, but I'll ask a simple question because we are getting late. So one of the biggest challenge I feel for ISAC is these ethical constraints. And these ethical constraints are from tracking people, from dual use, and so on and so forth. So would you like to comment something on this, because that is very important for acceptability of this technology?
So one comment from the panel, who would go for that? Christos.
I wasn't entirely clear about the dual use, but when you
military
right,
use as well.
Yeah, that's a difficult one to solve.
Yes.
I mean,
I can answer that one.
Yeah.
Okay.
Go ahead.
You go
if
for
you have
you go for the ethics, and I'll go.
So something that rang in my mind with ethics is that we also touched upon this, Julie, is the dilemmas between RF sensing and cameras. So there will be a valid debate whether you have pros and cons once you have sensing from the cellular infrastructure, replacing cameras that are a bit more personal, but then that sensing becomes more pervasive. So again, there's going to be trade-offs in how much you sacrifice in terms of privacy. And absolutely, I think that's going to be a significant barrier in implementing these. We've seen people burning down masts, 5G masts, for less of a reason. And that's why it's very critical to make sure that these are trustworthy systems, secure, private, and there's been a few comments about security and acting on it now. So I think it's definitely important.
Julie, you have a quick comment? We have two more questions.
But you mentioned dual use. There's obviously an advantage in it as well. So if you were to want to be monitoring people or things and keep people safe, I mean, there's an opportunity there.
Good. So, Mike, you have a question as well. So, sorry, Harold, you have a question as well. So, 3 questions from here and 1 from there. Yes. And we will be closing in 5 minutes as scheduled, right? So, Mike.
I think some very strong points were made earlier on about the importance of affordability, sustainability, and ubiquity. The GSMA Association forecasts 6.5 billion customers using mobile by 2030. But that still leaves a large number of people either not getting a service or access to the internet. And also it leaves a large number that perhaps need to be served better by 6G. So what can we do to improve affordability as well as sustainability and ubiquity to reach those people who don't even have access to the internet? So there are 2 growth areas which are use cases in themselves. We see streaming growing in terms of traffic. We see mobile money growing in terms of traffic. Are they drivers or something else going to drive the 6G investment?
Yep.
What is going to help the ubiquity?
So connecting the unconnected, overcoming digital divide. So who will take that brief answer? Yes, Kintaro.
I heard a person in some country in Africa, they have mobile systems, but they don't have electricity, so they cannot operate. Sometimes the mobile system itself is very, very expensive because they are integrated very high-level technologies. So to answer your question, maybe we need to select a proper system, maybe not the very, very high-end one. And we also need to think about the other social issues like electricity. Because so far, the mobile system industry tried to think about to get higher performances only, and sometimes forget about other issues. So that could be the problem. So maybe we need to think as a for social issue. This is not maybe the answer, but
no, but it serves the purpose. Very good answer. So just one question from here, and Harold, we are coming to you for the last question. Yes.
Hi, thank you. Wyn Meredith from the semiconductor ecosystem in South Wales. So the question I'd like to ask the panel is the semiconductor industry is an interesting place to be at the moment. And if you were to invest my R&D budget into semiconductor components that are going to solve critical issues in 6G, where would you invest it? Would it be in photonic, millimeter wave RF, terahertz components, or should I just stick to the power electronics to make everything more efficient?
So who would take that question?
I would say low power components. I would say low power components. FDSOI, for example, approaches for solutions, something like that.
Okay. You had a question, Harold? Yes.
A very simple question. Lessons learned. We have seen millimeter wave being a big hype. I've seen conferences full of papers, measurements. 10 years ago, it's not here. How can we avoid in 6G that hype technologies are sort of identified early on and demystified, so that we save industry a lot of money in investing into things that are not coming out?
Yeah.
I mean, a related question is coming to energy efficiency. We have seen that data centers are really bursting with energy consumption, and we talk about AI, and I don't want to say AI is not the right thing, but have we mapped the KPIs that the HexaX has brought out in terms of going away from KPIs and KPIs? One is net zero. Have we mapped these KPIs to the technologies as well, and who is doing that?
So figuring out technologies which have just created hype and which are actually promising. So, and just I add to that one, which was my last question, where is UK leader in technology and where UK is follower, and why we have to collaborate globally in order to achieve this. So maybe this one is the last question, so very briefly every panelist can contribute. So we can start with Christos. Yes.
Perhaps I take that point on the hypes because I see that connected to the previous comment on commercialization. So I mean, from an academic standpoint, I think the opportunities to implement and demonstrate things over the air, show them work, the advanced technologies, not the trivial technologies, is something that can be very valuable because often industry is a bit risk averse. So the risky things we need to be able to demonstrate and learn from that and refine the signal processing, the algorithms. And if perhaps one thing that comes out of these hubs is, and through Joiner as well and all that, is improving that opportunity for the UK, I believe then the UK can lead in this activity internationally. So having the opportunities, a streamlined opportunity to test our technologies and showcase them.
Julie?
For me, I think the UK is really leading in secure and safe AI. I think that we have had the talent in the UK for some time to be able to do explainability before people knew what it meant. I think we need to harness it in the telecommunications arena and bring these people in and to work with us.
Great. Emilio?
So I will not comment on the UK part.
Yes.
I will actually answer to
Compliment.
I guess we need some reality checks. First of all, is the hardware that will be available in 10, 15 years able to do what we asked to do? Because actually, most of the people works on algorithms, solutions, design, whatever, but then actually you have to, the reality check, for example, in mineral waste, or either the one we should have on Terra Earth is that actually. There's a dev valley of technology for which at the end we don't have the process for commercialize that. Second one is also about the usage. Because actually, for example, there's always this hype about the tsunami of data from AI. Now we see that with new technology, like for example, synthetic data and so on, this actual value measure is not as big as the other one. So when we do this, the feeling is that most of the time we, actually put also myself in that, we are so enthusiastic about something that we put actually the first justification to consolidate a reason to do something. Well, actually, so now you can really build a multi-level roadmap. For example, about the data explosion, you can really think about potential improvement. About the hardware, you can really see which are the stages needed. And for millimeter waves, it was clear from the beginning that actually there was a huge blocking problem.
Richard?
Yeah, so I mean, just two bits. You talked about AI and AI data centers, which are, you know, using enormous amounts of energy, and you know, one of the issues they have there is how they ship the data around within the data center. There's this enormous sort of multiplexing thing where, you know, the signals are shipped around by light, but they, you know, potentially go through 10 optoelectronic electronic conversions as they go from one place to another. And so if you came up with a better way of doing the networking, you know, the shipping of the bits from the place they originate to where they need to end up, you'd cut the energy consumption of the data center by nearly a factor of 2, apparently, according to... Now, people are working on that, and interestingly, you know, the likes of NVIDIA and Google and Microsoft are all working on it because of they know they have to sort of look as if they're getting to net zero, and so they need to reduce their energy consumption, and it's just going up exponentially. So that's one thing. But going back to quantum, which is, you know, the UK is probably was the top country for at least commercialising quantum 5 years ago. Other countries, the UK government was very prescient, and it invested a lot of money 15 years ago in the field. And it has built up a quantum technology industry. Other countries are rapidly catching up. So we announced our £2.5 billion quantum strategy a couple of years ago. I went on a DSIP organised quantum networks mission to the US last November. And that was about what the state of Michigan was putting into quantum technologies. So not as effectively as us, obviously, but there's definitely. I think we're still in a good position, but we are being caught up with.
Yeah. Kentaro, last but not least.
Okay,
yes.
so UK has very good leading technologies, but as in the previous sessions, the different countries has different technologies. So what we need to do is to integrate the technologies and create new visions and lead the industries to create new values in the future. So that's why we need to collaborate each other in the world.
Great. Thank you very much. So just before I close, yes?
One comment or question.
Yeah.
We talked about UK technologies that are coming out of the hubs, and something I forgot to mention in my previous talk. There's room 5 here in the building where some of the UK technologies are showcased. RSM, Bruno's work in Imperial, and some of our ones.
Okay. So just before we close, I really want to thank everyone, especially the panelists as well as the organizers. But I really wanted to apologize with those as well who may have raised their hand and we haven't noticed. So because of the limitation in time, we have to bring it to close. Just one thing I want to say is the summary of the panelists. There are 2 streams going on, right? So one is research and one is commercialization. And this happens in every cycle. So something will go into release 21 as the defined 6G, 3GPP standard. but research should continue, both in software as well as in hardware, because if it does not go here, it will definitely, somehow the good technology will find its way in beyond 60. Okay, thank you very much, everyone.